Hello, 7th grade math. Today we are in lesson 7.2, simplifying expressions. And before we get too far into it, we need to kind of determine what is an expression and what does it mean to simplify it. That's kind of the whole point of this lesson. But there's a lot of vocabulary in here that we really need to address before we get too far. The first piece of vocabulary that I'm going to give you is the word terms. Terms are pieces of an expression that are being added together or subtracted even perhaps. Pieces added together. Now the thing about terms are that sometimes they might just be simply numbers, but sometimes they might be multiplication problems, or sometimes we might add division problems together. So for example, we might have an expression that includes the term, I don't know, 3 times n, for example. 3 times n is a term, but then we're going to add to that 17. This is another term. So we have 2 terms here, 3n and 17. They are 2 terms in an expression. Expressions are pieces that are being added together. So this whole thing is an expression. We've got 1 term that's a multiplication problem. We have 1 term that is just a number. We call that a constant. We'll get to that in a little bit here. But then sometimes we also have what are called like terms. And this is a hard one for me to teach about because I always think of people that say the word like a lot, and it sounds like you're saying like all like the time, like you know what I'm talking about. But actually it is actually legitimately a math term. A like term are two like terms, I should say, are terms that have identical variable parts. Now, we really need to be picky when we say identical variable parts because like terms can sometimes be, they sometimes might look like terms, but they're not. And I'll show you an example here. For example, I'm going to use my other example here. I'm going to just kind of add to it 3n plus 17 plus 4n plus, and I'm going to throw one more in here, 3n squared. So in this example, now we won't see a lot like this, but I want to kind of point out a couple things. We've got 3 terms in here that have the variable n. But in one of them, my variable part is a little bit different because it's got this exponent tagged onto it. These are not like terms. These are not all like terms. However, the 3n and the 4n, the variable piece is just n. They are identical. The variable part is identical. N, this one is not identical because it's being raised to the second power. So that's what terms and like terms are. And today what we're going to do is we're going to be doing a lot of what's called combining like terms. So to combine like terms, what we have a great example in example 1, and we're going to get to that in just a moment. But I'd like to do another example first. I'm going to just kind of put one on the paper here. If we have 8x plus 24 plus 3x, we have 2 pieces that have like terms. So what I would like to do when I do this kind of a problem is on my very next line on my paper And honestly, if you get good at this, you can just do this stuff in your head, but I'd encourage you to write it out. My very next line on my paper, I'm going to copy down my problem, but I'm going to use the commutative property and put my like terms right next to each other. Remember, the commutative property says with addition problems, it doesn't matter what order it's in. I can rearrange it if it's all addition. So 8x plus 3x plus 24, that's the same thing as 8x plus 24 plus 3x. So commutative property says that I can do this. And furthermore, the associative property would tell me, go ahead and combine those before you do anything else. Okay, so now how do I combine this? Now, in order to combine this, it would not be what I would write on my paper, but I would like to demonstrate it at least. If I had 8 x's, one, 2, 3, 4, 5, 6, 7, 8. This is the same thing as 8 times x. And if I add to that 3 x's, x plus x plus x, this is 8x plus 3x. These parentheses mean nothing because all I'm doing is adding. Both of them here are just getting added. So if I'm adding x plus 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 x, how many x's do I have? That is the equivalent of saying 11x. These combine to be 11x. These also combine to be 11x. So the way we add like terms is we find the ones that have the identical variable parts, and then the number that's being multiplied by it, that's called the coefficient. Again, that's another term that's going to pop up in a moment or two. We take the coefficient and we add the coefficients together. So 8x plus 3x, 8 and 3 is 11 x's. And then the other terms from my problem just drop down into place in the problem. Now this is as far as I can go with the problem. Notice the directions at the top of example 1 asked me to simplify the expression. To simplify the expression does not mean that I'm going to end up with an actual answer. I'm just going to get it as far as I can. And the reason I can't go any further is because I would have to multiply before I add, but I don't know what x is equal to. So I've got this simplified, meaning I've made it as little complexity as possible. So I've got some complexity up here because I got the x's, I've got the x's, I've got them kind of separated. What I want to do is I kind of want to just make it nice and concise and write as little as possible. And that's my simplified expression, 11x plus 24. Okay, so now I wanted to do a problem like that before I did example 1, because example 1, I'm not sure why they did this, but they threw in something that's a little bit tricky. And in example 1, let's take a look at that one. In example 1, I see that I have 7c plus 9 minus 3c. Now this is kind of confusing, but when I'm simplifying expressions, I've got to be aware of pluses and minuses. These pluses and the minuses, they go along with the term that comes after it. Now this one doesn't have a plus or a minus because there's nothing before it. If it doesn't have a plus or a minus, we can assume that it is a plus or a positive. So plus and positive really mean the same thing. And really, I would encourage you to kind of think of each of these terms as these little boxes Now, you wouldn't necessarily draw the boxes like I did, but the plus signs and the minus signs, they go in the box with the term that comes after it. Therefore, this 3c is not 3c. It's actually a negative 3c. So minus 3c is the same thing as a negative 3c. So when I do this and I use my commutative property, I can change this up like I did before. And I have 7c. That's an odd color. I think I'm going to choose a different color. I'm sorry about that. But if I have 7c and I want to combine it with my like term, I've got to send this minus sign along with it. So 7c minus 3c, and then I can put my plus 9. So when I use my commutative property, as long as my signs go with the terms, it will work out okay. And a more complex reason for this would be that adding a negative is the same as subtracting the positive. So really, these two lines are the same thing. And you could use either one of these. Myself, I prefer this over this, but either one would work. So I'm going to work off of this one. It would be identical to working off of this one, but this is the one that I'm kind of focused on here. So I have 7c minus 3c plus 9c. Now this time when I combine my like terms, instead of adding the coefficients, remember that coefficient is the number at the beginning of the variable. Instead of adding the coefficients like I did over here, 8 plus 3 is 11x, I'm going to simply subtract. So if I have 7 c's and you took 3 of them away, I have 4 c's left over. So to simplify it, I have 4c plus 9. Now what? Well, now you're done. That's as far as you got to go. It's as simple as that. So below example 1, they kind of go through some of the extra vocabulary that I hadn't gotten to yet, that I said we would. One is equivalent variable expressions. Equivalent variable expressions are expressions that are equal for every value of each variable they contain. So in other words, what that is saying is that 4c plus 9, this is one expression, is equivalent to 7c plus 9 minus 3c. No matter what value you put in for c, it'll come out to be the same thing on the left side of this equal sign as it would if I plugged in that same value for c here and here on the right side. These are equivalent variable expressions. The coefficient of the term that has a variable is the number part of the term, but it's also worth noting that if I have a variable that doesn't have a coefficient, so for example, I might have 4x plus 12 plus x. Remember, like terms have the same variable part. So here's a variable part, x. Here's a variable part, x. Those are identical. These are like terms, 4x and x. But if I don't have a coefficient, then I have to know that the coefficient is actually 1. So x is the same thing as 1 times x. So when I combine these like terms, I'm going to use my commutative property and move 4x plus x plus 12. Everything else drops down. 4x plus x, remember my coefficient is 1. 4 plus 1 is 5x plus 12. And there's my equivalent variable expression, 5x plus 12. That's my answer. Let's move on to example 2. Example 2 asks me to identify the coefficients, constant terms, and like terms of the expression. I just realized that I forgot to mention that the constant terms, constant means that it doesn't change. Variable means that it does change. It changes depending on what x is equal to. So a constant is a number that does not have a variable multiplying by it. So in this case, 12 is my constant. Constants are very easy to identify because they just don't have a variable. In example 2, they give me what looks like a really ugly problem, x plus 4 minus 2x minus 10. Wow, that's quite a bit going on there. But it's really not all that complicated. I'm being asked to just identify the different pieces of this. What are the coefficients? What are the constant terms? What are the like terms? So my coefficients are remember, if it doesn't have a coefficient, it is 1. My coefficient here, now careful with this one, you might want to say that this is 2, but in actuality my coefficient is -2, because remember at the beginning of this video, or towards the beginning of this video, we said that the minus signs or the plus signs, they get grouped with the term. So my coefficient here is not 2, it is -2. All right? But that doesn't change the fact that x is a like term, or an identical variable part to the x over here as well. So just remember that in just a moment when we identify the like terms. I'm asked to identify the constants. In this example, let's see here, the constants that we have are the ones that don't have variable parts. My constants would be +4. And my constant over here is -10. Remember to group that negative sign in with the 10. That's very important. And this is +4. And then the last but not least part that I'm supposed to do in this kind of a problem is identify the like terms. So I've got like terms, and there's several, well, there's 2 pairs of like terms. The first one might be the obvious one, which is the x's. X and -2x are like terms, but then remember the definition of like terms is terms that have identical variable parts. What if my identical variable part is no variable at all? Constants are always going to be like terms. So 4 and -10 are like terms, okay? So let's kind of take a look at that 4 and -10 being like terms and see how that will play into simplifying this expression. If I have x plus 4, I'm going to copy this expression down one more time. Now, your book does not ask you to do this. I'm doing this just for fun. When I'm going to simplify this expression, again, my first step is I'm going to, either on my paper or in my head, use the commutative property to move my like terms next to each other. Don't forget the negative sign goes with the -2x. The positive sign is going to go with the 4. And the negative sign is going to go with the 10. So x minus 2x plus 4 minus 10. All right? So now my coefficient here is 1. It's a -2x. So now I've got to remember, well, 1 minus 2, 1 minus 1 would be 0. 0 minus 1 would be -1. So this is going to be -1x, or I can write -x plus 4 minus 10. It's a +4 minus 10. So I have 2 integers. One is positive, one is negative. They have opposite signs. I'm going to add the opposite, which means that this is 4 plus -10. To do that, I find the difference of the absolute values. 10 minus 4 is 6. And then I'm going to figure out which is it going to be, positive or negative. The negative 10 would have the greater absolute value, so it's going to be negative 6. Okay? So far I'm at negative x plus negative 6. That would be an acceptable answer. However, I would encourage you to simplify that one more step. When I have a plus negative here, I'm going to simplify that and say negative x minus 6 is my simplified equivalent variable expression. Now, what about in example 3, where I'm given some parentheses to maneuver around? I'm asked to simplify 5 times the difference of w and 4 plus w plus 8. Now remember, order of operations kind of tells me I have to do what's in parentheses first. But the problem with that in this case is that I don't know what w is, so I can't subtract 4. But the distributive property gives me a way to get around that. I'm going to distribute the multiplication that's happening outside here into the pieces inside. 5 times w is 5w. 5 times negative 4 is negative 20. I have 5w minus 20 as a result of that multiplication problem. Everything else drops down. And now I've got a problem back to like what I had in example 2. And I think I can do this one. Let's find out. I'm going to use the commutative property and move my like terms next to each other. So 5w and w are going to get moved next to each other. My negative 20 and my positive 8 are going to get moved next to each other. And now I've got 5w plus 1w. How many w's is that? That would be 6w. And then I have negative 20 plus 8. I have a negative plus a positive. Find the difference of their absolute values. 20 minus 8 is 12. And keep the sign of the greater absolute value. That's negative. So 6w minus 12 is my answer. There we have it. In example 4, I'm going to have you please read through that one on your own. That is some more of the same stuff, but they use some other formulas as well. So let's move on to our homework now. I'd like you to please do on page 324 the numbers 6 through 14 and numbers 21 through 25. Thank you very much. Have some fun.